The other thing, I guess, another theme, I guess, is the whole hardening of the authorize request, right? So because when you look at the threat models and so on, really the weakest link in the chain is still the authorized request because that goes via the browser, right? The browser is very powerful because it can show UI, it can follow redirects and so on, but the browser is also very problematic because, well, it can show UI, it can follow redirects, and those might go to the wrong place. So, and the way it typically works today in OAuth and OpenID Connect is that you just put the parameters on the query string. Right, so they are not tamper-proof or whatever. So people can start messing around with that and handcraft them, and maybe your system behaves in a way that you didn't foresee it. So one of the things that are now also almost finalized is called the JSON Web Token secured authorized requests, where basically instead of just putting them as key value pairs on the query string, you put them into a JSON Web Token, you sign the token, and then put the JSON Web Token on the authorized request, which means nobody can manipulate it anymore afterwards. Then you can go even one step further, which they call pushed authorized requests, is where you push the parameters on the back channel communication, just get back a reference to your parameters, and then just send the parameters on the front channel, which means no more parameters at all on the front channel. That's not quite sure if you're going to make that for the next version, but having the JSON Web Token ones first is definitely will happen, and then maybe the pushed ones come directly after that because it's actually just a simple extension on top. Cool. Let me think. What's the next big thing?
Refresh tokens.
Yeah, refresh tokens, I guess. So the motivation for also hardening refresh tokens even more is because now, with the deprecation of the implicit flow, right, people can legally, from a spec point of view, now use refresh tokens in their spas. And, they are a high-value target. So if you store them in the browser and you have a cross-site scripting attack, and stealing a refresh token is probably the best thing ever for an attacker, right? Because they are long-lived, they're not bound to the client, they can be used to get new access tokens, And you can apply a couple of techniques to make them more secure, like sliding expiration and shorter lifetimes and so on.
One-time usage.
One-time usage, and these are the things we already had since ever. But one thing that we don't have, which is really nice, is once you go to the one-time only semantics, you can also detect now if a refresh token is being used twice, right? Which basically means either someone stole it and tried to use it, or did the legitimate application try to use it after someone tried to use it as well. So basically, if you see the same refresh token twice, something is wrong. So then you basically can just use that to revoke all of them.
Is that going to be kind of like a security event almost, or is it actually something IdentityServer is going to react to?
Well, we have this refresh token service, right, which is an extensibility point. But our default implementation probably will be, if you see that same refresh token twice, just revoke them all. That's the safest thing to do. And if you want to then tweak that, I guess you would write your own or derive from ours and tweak that, something like this.
Okay, cool. I think the last thing then is probably mutual TLS. There's a bit more work on that.
Yeah. That was actually my hobby project over Christmas, to be honest. So the mutual TLS spec is basically, the bigger problem here is that we are kind of stuck with bearer tokens in the OAuth world. So bearer tokens, what it basically means is, bearer tokens are like money, right? If you find money on the street, you can use it. That's a bearer token. Whereas a credit card is more like a proof of possession token, where the card itself is bound to the owner, right? And there were so many different attempts to establish proof possession tokens with OAuth, like at the application level, then at the protocol level with token binding. This all never really worked out. So the only spec today that we have that is actually working, that is based on tech that is available to us, is mutual TLS. Right? So now many people say mutual TLS, that sounds like a headache, right? You have to have a CA and a PKI and all of these things, but that's not quite true. The mutual TLS spec allows for these enterprise-style scenarios with CAs and so on, but they also have a self-signed certificate way of doing it, where you don't need to have this infrastructure. You just register the certs and then you can authenticate using that client certificate. Now the nice thing is, once you have a client certificate, you can bind the key material of the certificate to the token, right? So basically you put the thumbprint of the certificate into the token, and when then the client uses that token with the same client certificate, the API can make sure that the TLS channel cert matches the one in the token, and if an attacker would steal that token, he couldn't use it because he's missing the private key. And the third thing that I then came up with is, what if you don't need to do any a priori cert registration at all? What about you just create a cert on the fly, right? And actually .NET, since version 2, .NET Core has APIs now to create certificates yourself. So basically what you can do is you just create a cert on the fly, you use that. You don't use it for authentication, you just use it to provide some key material to the token server to be able to bind the token. You can still do client authentication even with shared secrets, not that I would recommend that, but we have customers, for example, that use private key JOTs for client authentication, but you can't do token binding with them. So basically what they do now is they stay with the private key JOTs, which is a good authentication method, but then use just these ephemeral client certs for token binding.
Okay.
The catch here is a little bit that Windows is not good at supporting this, because in IIS the assumption always was that you establish trust before you can accept a certificate. So that was what took me the most time to figure out. And then I said, okay, I asked people at Microsoft and they said, yeah, that's the way it works. IIS was designed in a way that you first establish trust to the CA and then you can start accepting certificates, which prohibits the self-signed scenario, which prohibits the ephemeral scenario. But since .NET Core is now multi-platform, so I spent a little bit of time learning Nginx, and it turns out this scenario is super simple to implement with Nginx.
Okay.
Right? You basically just have an endpoint which accepts a random client certificate, right? All they do is validate the cert at the TLS channel. Then they pass you that cert to the application layer, and then you can use that cert to make your own association with the client or not, right? I mean, depending on how you use it. And it was actually a shame that I just spent 3 days trying to bend IIS to my will, and then it took me 30 minutes to get Nginx up and running.
Yep.
So that's my preferred new web server now.
Awesome.
Yeah, and besides that, there will be bits and pieces that people can go to the GitHub issue tracker, just have a look what's assigned to the 4.0 milestone. There are more things.
Yep.
We might not get to all of them, but if we can, we will. Yeah, but the things I just mentioned are the big themes that we're working on, and that's the ones we really want to have. And everything else, I guess, becomes backlog again.
All right, awesome. Oh, thank you very much.
You're welcome. Thank you.